All right, well, welcome everybody. Got quite a great crowd tonight. My first presentation of the evening will be Introduction to Overload. Anybody used overload.pm before? Yeah, I knew Chris would raise his hand over there. All right, I'm not going to have time, since this is an introduction. It's my disclaimer. I'm not going to get into a lot of the guts, just kind of give you a broad overview of what you can do with it, and then go into some specific examples, and then the rest of it's all in the fine documentation. Okay. Operator overloading, basically kind of a generic definition for it is operators have different implementations depending on the arguments. The arguments usually being an object of some sort. So normally if you've got a number plus another number, well, you know what it's going to do. It's going to add those two together and give you a number out. But what if you take an object and add it to a number, or object and add it to another object? Well, what's it do? This is how you can go about doing that sort of thing and having it do something that makes sense for adding two objects together. Just as an example off the top of my head, if you wanted to calculate price and you've got an object being returned by row price and row tax rate, and you multiply those two together, if you've properly overloaded the multiply operator, you'll get a number out, which is the amount of tax. So basically, yeah, I covered that. Just think that both of these are objects being returned here. All right, I'm going to kind of breeze through all of this. This is just to give you an idea of the scope of the things that you can overload. So you've got your arithmetic operations all through there, comparison, bit operations, increment and decrement, and I have to give the disclaimer, I stole this right out of the documentation, so you can see all this in there. But again, just to give you an overview that there is a lot of stuff you can overload. So Booleans, iteration, matching, dereferencing. This is, well, we'll talk more about this later. That one's really kind of fun. And then you've got some special ones. I'm not going to get into those. But any questions so far? I know it's extremely high levels so far. All right. You also have magic auto generation that goes on with overload. So what that means is that if you overload certain operators, it can figure out other operations, related operations, and auto-generate the code for you, with the disclaimer that it doesn't always do what you want it to do. So, you know, in my experience so far, I've had pretty good experience with it doing what I want it to do. But again, I copied that out of the documentation just as a warning. Doesn't always do. This is the minimal set that if you want, you can define all of these, and basically the idea is that all those others that you just saw on the other two pages will be, you know, auto-generated for you. So anyway, questions so far? Okay. Moving on. All right, now we'll get into some specific examples. This is actually just a test file for a class that I created that is doing operator overloading. But I thought it was, you know, nice, simple, straightforward examples of, you know, how it works. Can everybody see that, or should I enlarge it?
Increase the font a little bit.
Sure. Is that good? All right. Okay, so basically here we've got a number, and then I create a VA table cell object, give it a value of 42, and then basically I check, are they equal to each other? So basically this is now an object, right? This is a number, but I'm comparing a number to an object. But you'll see where the magic happens later. I'll get to that first. I just wanted to show you what it looks like on the front end before I show you what's under the hood. So again, addition, you know, now I'm looking for 43, so I take my cell object, which you remember has a value attribute of 42, add 1 to it, you expect to get 43, right? And on. Subtraction does what you expect. Multiplication, division, modulus. And then basically, I didn't do everything. I didn't implement everything. These were just like the common operations that I needed. If I wanted to, I could go in and implement more, but that's just how I decided to handle it, is just implement what I needed when I needed it. And if it turned out I needed more, I'd go back and add it in later. Any questions on this so far? Pretty straightforward? Okay, good. All right. Now we'll have a look at the actual module. All right, going to skip all this stuff, pretty standard stuff. Use overload. Okay, this is how you specify the operators that you're overloading, and then what gets called when Perl sees that operator being operated on an object of the type of, the cell object. So basically, I've got this value in order, which is doing kind of most of the work, and I'll explain what that does in a second. But basically, as you would expect, these are your two operands, right? X and Y, because you're adding two things together or subtracting two things. So that's why it's two things, until you get down to here where I'm doing stringify, and then it's doing something a little different. So first I'm going to explain the value in order, and then I'll come back and explain what's going on here. So any questions on this so far? I know it probably won't make a lot of sense until we look at value in order. Again, we're going to skip past new and initialize, all that stuff that you do. Okay, value in order, all it's doing is, the first thing is the cell. The second thing that gets passed in is the other operand, which is the one that's not the object. All right, that's what the other operand is. And the third thing is a flag that says whether or not they're supposed to be reversed. Because you could be adding a number, you could have the number plus the object, or the object plus the number, which order. So the flag basically tells you which way, whether or not they're reversed in position. So basically, all I'm doing here is getting the value from the cell object. You remember when I defined it in the test, that's what it had, was value equal, or is set to 42. And now I'm just pulling out that value. And then based on how reversed is set, I either put other operand first and then value, or value and then other operand. I just decide which order I'm going to put them in. Is that clear to everybody so far? So that's really all there is to it, is figuring out, well, which order am I going to put them in? And then here is where you do the actual operation on it. So X and Y, it might be that X is the object and Y is the number, or vice versa. And obviously that's what value in order does, is figures out which way they're supposed to be. Okay, what's going on here with stringify is I'm telling it, if you just put, quotes around the object, or put it in string context, just return the value. And so it just treats it like a string. So if the value was 42, as it was earlier in our tests, it would just return 42 as a string. And so you can use it in concatenation with print or sprint or f or whatever. So any questions there before I move on? So all right. Again, I'm just going to go through the tests here. Now we're looking at a row object. Okay, basically a row object holds several cell objects. That's kind of the way this works, is for me, in this code all belongs in a larger framework. So that's just to give you an idea that there are other things going on outside of this. But basically all we care about is that this is generating a table-like structure. It's got rows and it's got cells in it. So here with the rows now, I've got some different overloading going on. We'll kind of go through and I'll explain as I go here how it works. So first I'm expecting a list, 1, 2, 3, 4, 5, stuffed into an array. Excuse me, nothing big there. Then I'm creating a row object. I'm passing it reference to that array of data. And we'll see the magic that goes on how data actually gets translated when I get to the code. But what I'm doing right now is treating the object got, right? You remember it's a VS table row object. I'm treating it like an array ref. But I can tell you right now, the way this is implemented is the way I implement most of my objects. It's actually a hash ref. All right, just like you would, commonly do. Obviously, you can make objects out of a lot of different things. But, in general, a lot of people do it with hash refs. Excuse me. So, yeah, actually, if you don't mind, thanks. So, again here, now we've compared the entire arrays here by passing both reference, the expected and the object got. And then here I just pull out one value out of it, just the first value 0. So again, I'm treating it like as if it were an array ref, which you'll see later it is not. Thanks. And you can see here, I'm treating it like it's an array ref, and I'm doing a slice on it, right? 1 through 3. So I'm checking, did I get those 3 things? Yes, I did. You notice the numbers are different here just because because I'm getting a slice here, assigning it to an array, so everything's shifted by 1. So nothing tricky there, we just shifted by 1. All right. Now we're doing that hash reference overloading test. So I set up some field names and just map these, this is the name of a field, this is the position of the field, like the column number. And then now I create another row object. This time though, I pass it in, again, an array reference, but I also pass in the field names. So there are my field names right there. Now, I'm treating it like a hash ref, which it is. But the interesting thing is too that it doesn't even necessarily, that hash ref doesn't even necessarily have to directly contain those values. You can do it in other ways. And again, it'll make more sense when we see the code. But you can see here, I'm asking for give me Saturday, and then I'm asking for the field name Saturday, which again, you remember the values up there. Those values will match these data values here. And then again, I do it with a hash slice just to, prove to myself that that's working. And then I do it as comparing, the array off the array values versus the hash values that I had in my expected hash. And then Boolean overloading is, you can see here that basically if I got something here, or if I didn't get something, then it said Boolean false overload working, because you notice here, I set data to an empty hash ref, or an array ref. So that means that this is how I've decided that I want it to behave in Boolean context, is if it has no data fields, it returns a false. Now, once I add data into the object, now got becomes true because it's now got data in it. Does that make sense to everybody? I know this part's a little trickier than the first part. Just the arithmetic stuff is a little more straightforward. And then also I've got a row number test here, which is just keeping track of, which row number. That's pretty much metadata, so there's not too much interesting with that. So any questions there so far? Okay. All right, now we'll look at the code. This is where it gets fun. All right. Again, we'll ignore all this stuff at the top. Now you notice this looks somewhat similar, but you notice I don't have any flipping function that I call here or anything like that, because now I'm actually, instead of overloading an operator, I'm overloading the context, hash, hash ref versus array ref versus Boolean context. So in Boolean context, I'm saying return scalar and then turning that into an array of the reference that you get back from cells. And we'll see that a little later. But basically, just at this point, if you call cells, you get back objects if you've got data in it. If you don't, then it's going to return the scalar value of that. And when you do a scalar of an array, what do you get? You either get a true or false value, just a count of how many you've got. So it's either going to be true or false. If you have 0 objects, it will return 0, which turns out to be false. If you have a non-zero number, positive number of objects, then you'll get that number back. But for our purposes, all we care is that it's a true value. So, does that make sense so far? Okay. All right. Here, if I'm doing it as an array ref, you remember here I told you cells returns basically an array ref. Well, guess what? If I use it as an array ref, it returns cells, which gives us an array ref, surprisingly enough. If I use it as a hash reference, then it returns the fields. And we'll look again down here. This will make more sense when you see the code that actually does that. So we're going to skip all the setup code here. We'll look at, actually I'm going to look at data first, and then we'll go back to fields. Okay, you remember back in the test file that data was one of the parameters that I was passing in, either like an empty array ref or an array ref with a list in it or an actual array ref. So what it does is it takes, again, it's a reference, so it can be held in a scalar. I set up cells and then column numbers. And again, column numbers is just more metadata that you can get out of the object. But since it doesn't involve overloading, I'm going to kind of skip over that. So I just loop through each value that got passed in through data, right? And then I figure out the name, because you remember the other parameter we passed in were the field names. So it just figures out, based on the column number, which name it's supposed to use for that field, if you've actually got a value for field names. Then this, you remember, that's our cell object that we looked at earlier. We're creating a cell object for each piece of data, basically. That's what the loop does. And you pass in the value, which we saw that earlier from the test, but again, there's more stuff here. But this is, again, just kind of metadata. Row number, field name, column number. That's so that when you're actually using this stuff in some sort of a loop, each cell knows, a lot of information about itself. It knows which column position it's in, which row it's in, that sort of thing. It just makes it convenient that you can ask either the row object, which row number is this, or the cell object, which row did you come from. That's more or less why I keep that kind of information around. So then let's go back and look at fields. Did that make sense to everybody so far? Okay. Fields are basically, I'm just mapping between the column positions and the field names, right? So that's basically, I'm just storing that information, enough information so that when I treat it as a hash ref, it can map those field names I gave it to each individual piece of data that came in. I'm going to show you some. I know some of these examples are kind of lame in the tests. They're just simple for tests, but I'll actually show you a better example coming up. And then I just return again a hash ref, and I don't know if I pointed that out. Again, here I'm setting cells, the value of cells, to this array of cell objects now, but this also returns it. So when you call data, it also returns that same array ref of cell objects. Make sense so far? Okay, good. Haven't lost anybody so far. All right. Okay, this is the little more interesting example. Is that about good? All right. Okay, now I'm actually going to do something a little more realistic with this. I'm basically using DBI and an iterator, which we'll talk about later. Again, this is the database setup. Anybody who's used DBI has seen this sort of thing before, so I'm going to skim over that. You know, connecting to the database. This is just an SQLite database just to make things nice and simple. So it's just one file. If you're not familiar with SQLite, don't need, you know, a server, don't need no stinking servers or anything like that. Just very simple, because I just wanted this to be I didn't want this code to distract from the actual point of what I was trying to accomplish here. So basically I set up a contact table, which is really weak because it only contains first name and last name. Doesn't even actually have contact stuff. But again, this is only an example. So that's basically my select star from contact. And then I run an execute on my statement handle, and now I create an iterator. And again, I'm going to kind of skim over the iterator stuff for now, because that's actually comes later. So just for now, for our purposes, what's going on with the iterator is every time you call it, you call next method on it, it's going to give you the next record. That's all you need to worry about now. That's what it does. You say next, it gives you the next one. So that's basically our object. This is the actual code that gets that generates the iterator. But again, we don't need to worry about that now. Here's the main part that we're looking at, and the example is hashref overloading and arrayref overloading. So first I'll start with the arrayref overloading. I just say while my row equals SQL iterator next. And then I'm just doing, you know, joining of tabs, just showing you those, what's in there. And you notice again, I'm treating the object, the row object, as an array ref. So I just get to use a join on it as if it were an array ref, and there you go. And I'm going to actually execute this so you can see the output as well. So you don't have to take my word for it. Okay, and again, with the hashref overloading, you notice now I'm accessing the values by name, as opposed to just acting as if it was an array. I also could have done this in two separate blocks rather than using a join and done 0 in square brackets and 1 in square brackets. So either way, but I figured this was a better example because usually this is more the type of thing you would do if you had an array, is just run a join on it. So with a hash though, usually that's when you want to pick and choose. We could pretend there's, you know, another 10 columns in this table. But right now, all I care about is first name and last name. So I just pull them out by name and just, you know, format them nicely, and that's it. So we will go ahead and run this. Okay, this one. All right, SQL iterator. So you can see kind of what I was talking about. One of the columns that I wasn't mentioning earlier, because we didn't really care about it then, is this is the ID column. That's why we've got actually 3 columns here, because I've actually got an ID column for each one of these. So you can see that's all it does. Is since I'm doing an array, it just does a join on every single column in there, which is ID, first name, last name. And then here, I'm actually printing out the row number instead of the ID, and then first name and last name, which I'm just concatenating with a space in between them. Does that make sense so far? So the point of all that was just to show you that you can take, with overloading, you can take the same object, you can treat it like an array when it's convenient, or array ref when it's convenient to treat it like an array ref. When you want it to act like a hash ref, Just treat it like a hash ref, and guess what? It acts like a hash ref. So this, for me, is one of the convenient things, because I find that a lot of times, with my data, and I'm sure you guys have had this experience too, sometimes you want to treat it like it's an array, or sometimes you want to treat it like it's a hash, depending on what you're doing with it. You may want to access it by number or name, again, depending on what you're doing. Most of the time, if you just want a few things, you'd rather do it by name, because the code's more self-documenting that way. You can see exactly, as long as your names make sense, you can see exactly what you're after. So, any questions with this before we move on? All right, great.